Alright guys, welcome to 7.9. So we've been dealing in this chapter with exponentials here, radicals, exponentials. Now we're going to deal with patterns. So we're going to look at some sequences as it relates to these exponentials. Okay, so we're going to identify and generate geometric sequences today, and then we're going to relate geometric sequences to exponential functions. So real quick, make sure you get some of this in your notes there. So what is a geometric sequence? In a geometric sequence, the first term is non-zero. Okay, so we cannot start with a zero with one of these things. So the first term that we see in some pattern of numbers just cannot be zero. And each term after the first is found by multiplying the previous term by a non-zero constant we call r. Okay, so what I could do here is I could say, what if I start with 3 and my r value is equal to 2? Then if I am going to make a pattern, what it's saying here is I'm going to multiply the previous term always by 2. So if I have a 3 to start with, my next term would be 6. Then my next one would be 12. Multiply 12 by 2, I get 24, etc. Okay, so that's a geometric sequence in which I multiply the previous term by some constant we call r. It is also called the common ratio. The reason for that is if you were to divide and go the opposite direction, like if you had a group of numbers like this and you divided each term by the previous number, so if we did 24 divided by 12 for instance, and then 12 divided by 6 and 6 divided by 3, this is a common ratio between terms. Each one has a constant that's multiplying, and that is 2 in this case. Okay, when you reduce those fractions, it's called a constant. Common ratio, as I just said, is found by dividing any term by its previous term. Okay, so here this one's going down from left to right as we go down. So we're going to take the second term and we're going to divide it by the previous term. If you take 128 and divide it by 256, you end up with a half. So the common ratio is a half here. We're multiplying by a half each time. So if you see something going down, you know that it's going to be multiplied by some fraction. Okay, so then the arithmetic test, the numbers will go up or down by a constant difference. Imagine counting by a constant term. So with geometric versus arithmetic, so with arithmetic we use arithmetic. It's kind of funny that they have that spin off that word, but anyway, imagine counting by a constant term. So here I start with a 5, okay, and then I go to 10 and then 15. I'm not multiplying by a common thing, okay? I'm actually adding 5 each time. So I'm not multiplying with these arithmetic sequences. I am adding or subtracting. In this case over here we're subtracting by 3 every time. Okay, these can start with a 0. Right? I could start with a 0 and I could say the common difference between these things is 3 or something like that. And if I did that, you know, I could have 0, 3, 6, 9, 12, right? Very different from the geometric sequence, because if I started with a 0 here and multiplied that by anything, I would just be left with a bunch of zeros. Okay, so there's a little difference there between those two. Okay, so just know the difference between geometric and arithmetic sequences. So for the geometric test, the numbers will go up or down by a constant factor. Okay, this is what we've been saying all along. The first term will not be 0. The sequence will be multiplied or divided by a constant number. So notice here in the first example we start with a 1. Okay, I don't know why it says each term is multiplied by 4. I believe that's saying 2. It's supposed to be 2. 1 times 2 gives you 2, 2 times 2 gives you 4, 4 times 2 gives you 8, 8 times 2 gives you 16, etc. For the other one, we start with 500 and we're going down. Okay, so here each time we're dividing by 5. Okay, and if you wanted to know what the factor was, you can always take the second number, which in this case is 100, and divide by the first number. So 1/5 is the multiplier. Each time, if I take 500 times 1/5, I get 100. 100 times a fifth is 20. 20 times a fifth is 4. So you can always write it in terms of multiplication. Okay, so that's why we call it a factor. You can think of it as division as well, but either way. So example 1 says, is this geometric, is this arithmetic, or neither? Explain. Okay, so let's see what's happening here. Let's see if we're adding things here, if we're multiplying in this pattern, what are we doing? So in this one, we have a 1, and then we have a 3, and then we have a 9, and then we have a 27. It appears to be growing pretty quickly, so I'm assuming we're multiplying. So I'm going to just try multiplication. So 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. So this was going to be considered geometric. And the explanation for that is because each term is multiplied by the common factor of 3. So you can write something like that out. That's the only one I'm going to write out like this, but that's kind of how you would explain that. Then let's look at the next one here. So we're going from negative 20 to negative 15 to negative 10 to negative 5. So here, it doesn't look like multiplication's happening. It actually looks like we're counting by 5. So I'm going to add 5 to each one, make sure that that works. And it turns out that it does. So since we're adding 5 each time, this is arithmetic. Okay, so when you explain that, you say it's because we're adding each term. Each term is being added. Well, you can add 5 to each term to each next term is essentially what we're doing. Then let's look at 1c. So this one here, it appears like, if I multiplied by 4, 2 times 4 is 8. 8 times 4, though, is 32, so it's not multiplication. So now I'm going to try addition. Okay, so if I add 2 plus 6 is 8. 8 plus 6 is 14. Okay, so far so good. If I add 6, though, to 14, I get 20 instead of 22. So notice here, there's nothing that, there's no strong pattern throughout the end. We're not multiplying here. We're definitely not adding here. So this is going to be a neither. Okay, so there's an example of a neither. Okay, so geometric sequences. This is the focus of this lesson. To find the next term in a sequence, here's a couple of steps that you can do. Okay, so if you wanted to find the next term in a sequence, first of all, what you have to do is you have to find the common ratio. Okay, that is taking this, the next term and dividing it by the previous term. It's called the common ratio. Then we're going to multiply each term by that common ratio to find the next term. So it's all about finding this common ratio, we call it R, and then we're going to use that to find other parts of the sequence. So let's try it out. Here, for example 2, they want us to, and I believe the directions here are to, give me the next couple terms in the sequence. So let's see what's happening. If I go from negative 3 to 15, what I'm going to do to find out what's happening here is I'm going to take the second term and divide it by the first. Okay, so if I do that, 15 divided by negative 3 gives me negative 5. So what's happening here is I'm multiplying by negative 5, and then I might test that, right? So 15 times negative 5 gives me negative 75. Take that times negative 5, I get a positive 375. So I know my next answer is going to be negative. Okay, so if I take 375 and multiply it by negative 5, let me just get my calculator out here to speed things up. So I have 375 times negative 5, I get negative 1,875. Then if I multiply that by negative 5, I get positive 9,375. Multiply that by negative 5, and I get negative 46,875. Okay, in your directions, be careful with your directions. I don't know what they're going to have you do. They might have you find the next term or the next 3 terms, something like that, but you're using the pattern to figure out what those would be. 2B, I would like for you guys to try this one out on your own, kind of using the same strategy that I just did. Okay, let's take a look at this one. So here, we're definitely going up as we go from left to right. Let's see if this is truly arithmetic. So if I take 36 and divide by 24, that should give me my R. Okay, so if I take 36, divide by 24, I get 1.5. Okay, so let's just make sure that works. So if I take 36 multiplied by 1.5, I do get 54. If I take 54 multiplied by 1.5, I do get 81. If I multiply 81 by 1.5, I get 121.5. so that might be my next term. If I multiply that by 1.5, I get 182.25. And then maybe I'll find one more. If I multiply that by 1.5, I end up with 273.375. Okay, so that's how that works. Don't worry if these go to decimals after these whole numbers, because you know, that could happen once you get to this. Once you get to this odd number here, things are going to go to decimal. Okay, so next, before we get into the final example, we have to think about what the nth term equation would be. So they're going to have you come up with an nth term equation for these things. So essentially all we're doing here is we are multiplying each previous term by a common ratio. So the nth term, if I'm looking for any term in the sequence, the nth term, we call that when it's just, you know, any term you want to find. What we're going to do is we're going to take the first term in the sequence. We call that a sub 1. So these little subs, when you see these subs here, these subscripts, those just mean, when dealing with sequences, those just mean the term in the sequence. So if I said like a sub 23, that means that we're talking about the 23rd term in the sequence. Okay, so that's what that little subscript means there. So a1 means the first term. Then I'm going to multiply that first term by the common ratio, which we've talked about, how to find that, right? The common ratio. Okay, all to the power, and this is where these exponentials come into play, the power of n minus 1. Okay, so what that means is, let's go back to the 23rd. Okay, so if I was going to find the 23rd term in the sequence, what it would be is, I would say, okay, A23, the 23rd term, is equal to the first term times the common ratio, all to the 23 minus 1. Okay, so whatever term I'm trying to find, that is the n, right? So this is the n piece here. So this could simplify to the 23rd term is equal to the first term times the common ratio to the 22nd power. All right, so that's how we figure this out. Now, let's try one out. So it says write an equation for the nth term of the geometric sequence 96, 48, 24, 12. So it's going down, right? So how is it going down? Well, if you didn't know, you could take the second term divided by the first term. Okay, and this will give you your multiplier. So if you take 48 and divide it by 96, you're going to be getting 1/2. Okay, so r, to find r, I take the second term divided by the first term. R is 1/2. Now, they want us to come up with the nth term equation, and then they want us to find the 10th term in the sequence. Okay, so we need these three pieces of information to come up with our equation. A1 is 96. R we just found, which is 1/2. N in the second case here will be 10 when we eventually do it. But for now, we'll leave it in terms of n. Okay, so the nth term equation is going to be this. The nth term, whatever term I want to plug in there, is going to be equal to 96 times 1/2 to the power of, and I like to put that in parentheses a lot of times so that people know it's just to this, the exponent is just applying to the half, all to the power of n minus 1. Okay, that's my nth term equation. Now let's find it for 10. Okay, so for 10, let's do this in a different color here. So for the 10th term, we're going to say 96 times 1/2 to the 10 minus 1. That simplifies to 96 times 1/2 to the 9th power. Okay, so if I take 1/2 to the 9th power, and I'm going to do that in my calculator, but it's the same thing as 1 to the 9th power over 2 to the 9th power. 2 to the 9th power is 512. So this is the same thing as 96 times 1 over 512. Okay, so if I multiply 96 by that, what I end up with is this decimal 0.1875. Okay, so the 10th term, if you keep going down by a half, the 10th term is going to be 0.1875. If you're on a test and you want to kind of test this, we already know this is term 1, term 2, term 3, term 4. The 5th term, if we cut that in half, would be 6. The 6th term, cut that in half, would be 3. 7th term would be 1.5, right? And then the 8th term would be 0.75. And then the 9th term would be, let's see, half of 75 is 0.375. And then half of that would be my 10th. So look, you can test it like that as well. But I'm probably going to give you something ridiculous that's going to be hard to test, so that I'm going to kind of force you to use this equation on the test. Okay, so I might ask you, like, what's the 23rd term or the 24th term or something like that. All right, guys, that's it for now. We'll have homework sheets ready in class, and we'll work some of these together. See you.